Okay. Okay. Hello. Welcome to How to Monkey. In today's video, we will be explaining, how to do limitations basically for lesson 1 basic calculus. So as you can see here, we're doing the graphing method since we have a graph right here. So we know that this is the origin and the origin is 0, okay? Now, once we go up from the origin, we are changing the value of our y. And once we go left or right, we are changing the value of our x. That's the basics of ordered pairs. Now to get the limitations, we did the the table format a long while ago. So now we're doing the graphing. So for example, you're given this question, right? F of -4. Now, once you're given this type of question, f of -4, you must always think, okay, my -4 right here, yes, this is the value of your x. So now we have our x. What are we looking for? We're looking for our y, okay? This is what we're looking for. So what is the value of y when our x is -4? Now let's look at the graph. Where is -4? So we know that if you move right, it's positive in the x-axis, and when you move to the left, it's negative. Okay, so we have -4, so it must be on the left. Okay, here it is, -4. 1, 2, 3, 4. Alright. Now, what is the value of y when x is -4? Now the answer is D and E. It does not exist. Okay, now why does it not exist? Well, you see here, going back to our previous lessons in Gen Math, when there's a circle here that is unshaded, that technically means that it does not exist because, well, it exists, but it's not a part of our scope. It's beyond the limits, so it does not exist. Unshaded, shaded, unshaded equals D and E. Okay? They serve as lines, as they still exist in the lines, but they do not exist. This goes the same for here. You see, if we had no line here, and if it was just for let's say it was just this, right? It was just this, and this was the value of this was -4. If there's no shaded circles like right here, or even if there's no unshaded circles like this one, it will still be D and E because there's no shaded circle, which means it's not part. That's the basic terms. Don't go too deep into it. But now let's go to f of 5. Okay, let's find 5. 5 is right here. Now, what is the value of when x is equal to 5? You see this shaded line, this shaded circle here? Now let's count from the origin, which is 0, 0, and let's move up until we hit this dot right here. So that's 1, 2, 3. Now we know that the value of f of 5 is 3, positive 3. Why? Because look at this here, it's on 5 and it has a shaded circle, so that means that's the value of y when x is equal to 5 as given right here. And then this lesson is from what I understand, by the way. Okay, so let's continue. F of 2, let's look here. We know that it is on the x-axis and it is positive, so we move to the right by 2. 1, 2. Okay, now what's the answer here? I'll give you a second to think. All right, yes, it is DNE. DNE. It does not exist because, again, look, unshaded circle, and there is no other line that has a shaded, there is no other circle below or above it that is shaded. Now, for example, we had something like this. We had something like, let's go here. We had something like this, where this right here was 2, right? And on top we had a unshaded circle, and the bottom we had a shaded circle. Your answer here would not be D and E, because if you disregard this right here, if you disregard that, you still have this, and this definitely does exist. So whatever is the value of this shaded circle will be the value of your 2. All right, so let's continue to -2. Let's looky here. Oh, that should definitely be oh yeah. Well, I've given it away, but I'll give you a second to think. And yes, the answer is 1, 2, -2. Now, why is it -2? Because as you can see here, our x is -2, so we moved left 2 times, 1, 2, and we're gonna find a shaded circle. Now, where's a shaded circle? Above, nothing. Below, oh, looky here, 1, 2. This is -1, -2. So the answer is -2. Now let's look at -5. -5 is that's +5. My bad. Here, -5. You see here, 1, 2, 3, 4, 5. Now there's a dot here, and there's a dot here. Now, which one do we use? You're right, the dot at the bottom. Why? Because this is shaded and this is not. We do not work with this because this does not exist while this does. Let's make that more visible. All right, so let's continue. The answer for this, if you can see, 1, 2, it's still -2. Now let's go to f of -3. Now, where is -3? -3 is right here. Now, I'll give you a second to think what the answer is for question number 6. You're right, it is 0. Now, if you're wondering why it is 0, there is a shaded dot right here. And we know that y at the origin is always 0 because we only move left and right, and there is no changing of the y-axis, and it's just staying on the x-axis. Now, if a dot is on the x-axis, that means that its y value is always 0 because it did not move up nor did it move down. It only moved left or right. Now that we had that, let's continue. Now we know that this is question 6, so let's continue to the actual limits, okay? Now we have lim f of x as x goes to -4. Now, what is this? What is this exactly? What is that? If a number has that symbol right next to it in limitations, we know that it is left. We're trying to find its limit from the left-hand side. This is called the left-hand limit, or the left side limit. So we know that -4 is right here. And how do we find its limit on graphing format, right? Oh, I don't know. We don't know. So let's find out. So if it has this, remember, if it has this, it's on the left. You're trying to take into account what's going on from the left of this number, from the left of this number going to this number. So what's from the left of -4? Well, we see -5, right? Now, what we're trying to do is find the y value as we get closer from -5 to -4. Now, how do we do that? So we take into account, okay, let's go to what's closest? Let's start with negative 4.5. Let's go to the middle. Okay, now this is the middle, right? Imagine that this is the middle. Now, what I want you to do to make this easier, for starters, I want you to let's make imaginary lines. Okay, now that we've made imaginary lines, we stop making our imaginary lines once we hit the real line here that is already given. Now, after we hit the real line that is given, we make another imaginary lines. This time, instead of vertical, we make it horizontal towards the y-axis. Now let's make our imaginary lines right here. Imaginary lines. And we've hit the y-axis. Now what is the value of this right here? Well, we know that the value of that is 1. Okay? Because it moves exactly one spot away from 0 upwards. Because downwards would be -1, so upwards would be +1. Now that we've made a imaginary line to here, -1, +1, we know that if our x was -4.5, our y would be 1. Now let's try to get closer, okay? Let's go to here. Let's imagine this to be -4.1, okay? Right here, 4.1. Now we make our imaginary line again, and then again, over here, and we still get 1. So now that we know that even if you get to, let's say, -4.00001, its value, its answer will always be 1. At least that's how it is from the left side, because we're considering the left side here, right? Because it has this symbol right here, the negative symbol. Now let's move on to number 2. What if we consider the right side? This symbol asks for the right hand limit, or the value of y when x gets closer to -4 from the right side. Now the process is the same. We get, for example, you can go to as close or as far as you want at the start, but this time let's start from as far as we can, right here, right? Let's start right here. We make our imaginary line, and then we touch the line. Now we move horizontally towards the y-axis, and we've touched it. What is this? Now, I don't know what this is, but this is something that is 0 point something, right? But it's closer to 1 than it is to 0. That means that if we round it off, it will be 1. But let's get closer. So let's move to here. 3.9, let's say. Now we do the same process, and then we make our imaginary lines horizontally, and boom, we get 1. So we know that the value of y from the right side, or the right hand limit, is 1 as x gets closer to -4. Now, for number 3, what does this mean? As x approaches to -4 without the symbols, that means that you consider both sides. So instead of considering one side's like here, where you consider left if it's negative and right if it's positive, if it has no symbol here, that means that you're considering both sides. So this is called the, I'm pretty sure, the two side limit, or the double side limit, I'm pretty sure. Correct me if I'm wrong. But now you consider both sides. Now, we know that from the left, the answer is 1, and from the right, the answer is 1. That means if they're similar, then the answer is also 1. Now why is it 1? Because from the left we got 1, and from the right we got 1, right? So if we consider both sides, the answer is 1. That means, because here we consider both sides, the answer is 1. But what if they were different? So take a look at this. As x approaches to -1, lim of fx as x approaches -1. Now there's no symbol, that means we're considering both sides. So where is -1? -1 is right here. Now if we go back to our lesson in Gen Math, this is called an asymptote. That means this is a place where any line from this side and any line from this side cannot touch this line right here. It cannot go past it from the right, and it cannot go past it from the left. It just cannot. That's how it works. Don't think about it too much. So as x approaches -1 from the left side, how does it work? What will be the answer? Okay, so let's take a look at -1.5 right here. -1.5. If you make your imaginary line right here, boom, 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 and you go boom, 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 we know that, oh, what is this? It gets to 0 because it's closer to 0 than it is to 1 here. But let's go closer. Let's say it's -1.1 right here. Right here. Boom, 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 boom. Now we know that, hey, boom, 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 imaginary line. But what is this arrow? This arrow signifies that the line goes on forever. And what does it mean if the line goes on forever? If the line goes on forever, then your answer is infinite, or positive infinity in this case, because it goes up. If it was going down, it would be negative infinity. But in this case, it is positive infinity. Now let's go from the right side. -1 from the right side. Now let's go here, same process. We go here, up, 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 and this also has an arrow. So that means that both of these are positive infinity. Positive infinity. So if they are similar, which they are, because both from the left and from the right, the answers are positive infinity as they get closer to -1. That means our answer for number 4 is positive infinity. Forgive my very, very poor drawing skills and very poor yeah. Let's move on. Now let's go to as x approaches to 2. Now we're still considering both sides because there's no symbol here, like what this is right here. So where's 2? 2 is right here. Now, as x approaches 2, you might be confused. Hey, there's a blank, there's an unshaded line here. That means it's DNE. No. If it's looking for the limitation, it's only DNE, or does not exist, if and only if your answers from the left and your answers from the right are dissimilar. So for example, if from the left your answer was 3 and from the right your answer was 2, now these are not equal. So that means it is DNE. So let's move on. What is the value of y as x approaches to 2, right? With our this is our limitation. So from the left, from 1, we go as close as possible. Boom, 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 boom. And then we go boom, boom to here, right? And what is this? 1, 2. So it's 2. Now let's go from the right. Close as possible. Boom, 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 boom. and then we move boom, 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 boom to the y-axis. So it's always a vertical movement and then a horizontal movement. And then it's still 2. And they are similar because from the left it is 2 and from the right it is 2. So our answer here is also 2. Now moving on. Limitation f of x as x approaches to negative 2. Now where is negative 2? Negative 2 is right here. Now let's make our vertical line from the right this time. So as close as possible right here. And then we move up and then we move right here, right here, right here. So we know that the answer from the right is 0 point something, right? 0 point something. But from the left, the line's moving down. So that means we can't go up because we're supposed to follow where the line is going. If the line is going downwards, our imaginary line goes downwards. If our line goes upwards, then our imaginary line follows it upwards. The only constant is that you must always find after the vertical movement its horizontal movement to find the value of y. You get closer to the y-axis, hence the horizontal imaginary line. Now let's get as close as possible to negative 2, which is somewhere around here. And now we move downwards. Now what is this? What is this? Negative 1, negative 2. The answer is negative 2 for here. But here the answer is positive 0 point something. What does it mean if they are unequal? You're right. The answer is D and E. So the answer for number 6 is D and E. Now let's go to our final number. Lim f of x as x approaches to 3. So our 3 is right here, as you can see. Now from the right, let's go from here as to the middle. Up, 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 up. This is 1, right? You don't have to make the imaginary line, but if you do, you have to, then do it. This is 1. The value of this is 1. Now let's get to as close as possible. Up, up, up. Then to the y-axis. Now we know that the value of this is 0 point something again, right? 0 point something again, which if you round off, which always round off, always round off, okay? Always round off to find the exact number because that is what's needed and that is what we were taught. And moving on, as close as possible, it's 0 point something. Now from the left, if we get to the middle, you'll see that it's different. It's 2. And if you get as close as possible, you can see that it's still 2. So 0 point something and 2, are they equal? They are not. That means that the answer is D and E. D and E. Now that is it for the lesson. We answered 6 questions here and 7 questions here. 6, 7. So to sum it all up, from here, just this is value of x, look for value of y. If unshaded line doesn't exist, if unshaded line doesn't exist, if shaded line, it does exist. If there is unshaded and shaded, always look for the shaded, and that is the value. Now for here, for limitations, if has this symbol, the negative symbol on top, that means it's asking for its left hand limit. If it's positive, it's right hand limit, going from the right and going from the left respectively. Now these arrows signify infinity, and if they similar, your answer is infinity. It is only D and E in the limitations area if they are different. if they are dissimilar. That means your answer from the left hand limit and from the right hand limit do not equal each other. This will make do not exist as the answer, as shown in number 6 and number 7. Otherwise, your answers will be equal. And that is it for this lesson. Good night.